Assalamu alaikum. This video for Unit 6 multiple choice questions. Question number 1. Now, actually to save the time, I will give you like a few seconds. You can stop the video, read the question. And I will start with the solution. Please read the question very good, okay? It's very important to understand the question. Now, to rank the work, we can remember that work equal to the area under the graph. So, as we can see here, actually if you want to calculate it, you can calculate it. If you want to look at the squares here and count them, 1, 2, 3, 4, 5, 6, 7, 8, so 8 squares. Here, 1, 2, 3, 4, 5, 6, and we can say 7 and 8, so same. Here also 1, 2, 3, 4, 5, 6, 7, 8. So we found that for disk 1, 2, and 3, the work is constant. For disk 4, we have more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's say 11, 12, and almost 12 and 5 and 0.5. Since we don't need to find the exact number, it's okay to just estimate it. So the final the answer is D. W4, omega 4, the work for disk 4 has the, not omega, sorry, the work for the disk 4 has the greatest work, and the others are the same. Next question. Also, please pause and read. Okay. Now, the total work. Actually, again, here, the work equal to the area under the graph. We can say for first stage, the work is this graph, area under the graph. And for the second one, this is the work. No, this is not the work. Actually, this is a common mistake. Don't ever use let's say, always keep in mind that area under the graph is between the graph and the zero, the graph and x-axis. Here, we need to be careful that this is the work under this graph. So under, not exactly below, actually it's between the graph and the x-axis. So work 1 equal 1 over 2 times, how much? Times 1 times 15. That's equal 7.5 joules. Work number 2 equal 1 over 2 times negative 5 times 3. That's equal negative 7.5 joules. So the total work is 0 joules because 7.5 and negative 7.5 will cancel each other. So total work is 0, and the answer is total work is B. Total work is 0. The rotational kinetic energy is maximum when theta equal 1 actually. Why? Because at this point, the work is whatever in green. When we increase theta, now we need to subtract this part. We will, at theta equal 3, we need to subtract all this. Clear? So at the beginning, we had only the green, when theta equal 1, we had only the green part, the work was maximum. Next question. For this question, we need to find the linear momentum, the rotational momentum or angular momentum for this object. Actually, we used this formula when we also solved the free response. L equal mvr. L equal the mass is given, which is 2 kilograms, multiplied by the velocity, which is 0.8, multiplied by the distance, the r, the radius, which is 4. Actually, we need to be careful. R here is the perpendicular distance between the path and the pivot point. So the path and the pivot point are parallel. The perpendicular distance is 4 meter, which is y, okay? Now L equals 6.4, طبعا this is using the calculator, kilogram meter squared over second. This is the right answer. Same question is repeated here, but in different words. If you read it, please. L equal mvr. L equal 2 times 0.8 times 4, even same number, which is 6.4 kilogram meter squared over second. This is the final answer. Now, solid cylinder, please read the question. We need to find the total kinetic energy. This object has two motions, two kinetic energies. There is the rotational kinetic energy, and we have the translational kinetic energy. The rotational kinetic energy is 1 over 2 I omega squared. The translational kinetic energy is 1 over 2 mv squared. So the total kinetic energy equal 1 over 2. What is I? I is the rotational inertia, which is given here in the formula, in the problem. So it is 1 over 2 times m c times r c times squared. And be careful, the 1 over 2 here is different than the original 1 over 2 in the formula. So don't confuse. We have two halves here, 1 over 2 and 1 over 2. Okay. That multiplied by v squared, omega squared, sorry. And we know that v equal omega times r, omega equal v over r, right? So instead of omega squared, we can write v squared over r squared. The plus 1 over 2 m v squared. The kinetic energy equal 1 over 4. طبعا here r squared with r squared cancel each other. صار 1 over 4 m v squared, that's plus 1 over 2 m v squared. 1 over 4 plus 1 over 2 equal 3 over 4 m c v squared. This is the final answer, which is C. Next question, please. Read it. Between point X and Y, actually, what will happen to the angular momentum? It will remain constant because there is no external torque acting on it. No torque external. or because torque external equal to 0. Okay? Next, for this one also we can use almost the same logic. The angular momentum is constant because there is no external torque, but the kinetic energy will be changed. Why? Because the velocity is different. The velocity is different. The velocity will increase when the object is closer to the central object. So يعني V increases as the object come closer to the central object. Okay, so that means, yes, we agreed L is not changing, so we cancel this one and this one, A and B. Now, since V is increasing, when it comes closer to the object, to the central object, and the question is asking about which one of those is right. Now let's see, and Q and R. Q is closer, so Q is faster. That means the kinetic energy here should be greater than the kinetic energy on R. So for this one, this is right. So, and also this is right, so C is right. If we look at the others, KB is less than KT, which is not right because here it's faster. That means greater kinetic energy. So this one is wrong. Last one, HR greater than HT. Also, it's not right. Clearly, HT is closer to the central object than R. So the only right answer is C. So C is the right answer. Thank you.